Now we have covered the rules for applying oxidation numbers. I am now going to look at some past exam questions. Now it is imperative that you note the year and the number of the question for each of these, and that you find some time later on to go back on them, okay? If you have exam papers, well and good. You can look them up online on the State Exams Commission website if you want. But I would like to think for the moment that you know that I will put it on the screen here. I'm aware you may not be reading it very well, but you must have the number. And I will go through the solution to each. I'll do more recent ones for the moment because I want, these are guaranteed marks and you could do very well in it, okay? So now we are down to here at the moment. What I've dealt with is number 6, identifying and using oxidation numbers for identifying and balancing equations. In our next unit, I will be showing you how to test for an oxidizing and reducing agent in the laboratory. And we have to do the mandatory experiment relating to halogens as oxidizing agents. That'll be the next unit we'll be doing there. I'll be asking you to add a number 8 to this study plan in due course. So will you take it, please, that you know that's very important. I'm of the opinion now everybody has this study plan, and that you also have the set of notes on oxidation and reduction. Right? You don't need anything but an A4 pad for the moment now, please. So will you work on this? The first question I'm going to deal with today now is 2016. Okay, 2016, and it is question 10B. Will you please make a note of that now? It's very important. Okay, 2016, question 10B. Now, you can see it right here. Look, this one, and the two equations are given to you. Now, I'm very aware of the print and all that now, but you do need to be aware. Define reduction in terms of electron transfer and change in oxidation number. Okay, in terms of electron transfer, reduction means a gain of electrons, oil rig. Reduction is a gain of electrons. Change in oxidation number, reduction means a decrease in oxidation number. 2 nice 3 markers there, 6 marks. You're given these two equations. They're full equations given to you, all the ions and all that with them. Assign oxidation numbers in the first equation above to identify the reducing agent and the oxidizing agent. And then it asks you to use oxidation numbers or otherwise to balance either equation. Or otherwise, I wouldn't take that on if I were you. Okay? You'll have to use oxidation to balance either equation. I'll do both for you so you'll see what I'm at. Okay, I'm going to do that then. We must record the equation. I'll record the equation again in red and I'll write the oxidation numbers in black. Okay? I hope that will be okay for you. So the first equation is ClO minus. That's hypochlorite ion, by the way. You don't need to know that now. And this is thiosulfate, S2O3 2 minus. Later in your syllabus, you'll come across iodine thiosulfate titration. That's a bleach. That's the bleach titration, by the way. That's neither here nor there. Plus OH minus goes to Cl minus plus SO4 double minus plus H plus. And I have to work through that now, and we have to balance that. What it said was assign oxidation numbers to the first equation above to identify the reducing agent and the oxidizing agent. I'm going to do that. Here we go then. Oxygen is -2, so that chlorine must be +1. It's a complex ion, and they must add up to the charge on the ion. Oxygen is -2 3 times, so the sulfur must be +4 to make that -2. Be careful, +2 twice. Very important now. If you put +4 there, that will be very serious because you come to the wrong conclusion. Be very careful with it now, please. And this one then, hydrogen is +1 and oxygen is -2. Simple ion -1, oxygen is -2 4 times, so the sulfur must be +6. And that's a simple ion +1. Now, are you all okay with that? I'm just checking my board now to see that's legible for you. That's fine. Okay? And I hope you're able to work your way through that now. I'm going to work on it for you. Right? Assign oxidation numbers to everything. Identify what is oxidized and reduced. Starting from the left. Chlorine is +1. Chlorine is -1. Very good. +1 and -1. That means it's increased by 2. Okay, no, sorry, it's decreased by 2, +1 to -1, decreased by 2. That's reduction, that's a gain, and it's a gain of 2 electrons. Are you okay? +1 and minus 1. Be careful with that now, okay? Gain of 2. It's reduction, and reduction is a gain, and that's fine. All right. Now oxygen, leave it. Okay, minus 2 and minus 2, the same on both sides. Sulfur plus 2 and sulfur plus 6. I'm bringing the arrow down here and across here. Plus 2 to plus 6. I could write that up a bit further for clarity. That's plus 2 twice. Now, do you realize if you wrote a plus 4 there, you'd be in all sorts of trouble because your numbers wouldn't balance. Okay, very important. Okay, plus 2 to plus 6 is an increase. That's oxidation, and oxidation is a loss, and it's a loss of 4 electrons. A loss of 4 electrons. Okay, very important. And you're on your way with that. There shouldn't be any issue there. Okay, if you do, there won't be an issue there. So that's what you have to deal with, right? Oxidation and loss of electrons. And we must balance the electron transfer. Now, before we do that, let's answer the question. Assign oxidation numbers to the first equation above to identify the reducing agent and the oxidizing agent. Do you know what is the reducing agent and what is the oxidizing agent? The reducing agent is oxidized. So that is the reducing agent. Okay, S2O3 2- is the reducing agent. Okay, because it's been oxidized. And that has been reduced, so it's the oxidizing agent. Okay, that's the hypochlorite ion. You write down ClO- and tell me it's the oxidizing agent. Now, a lot of people lose marks here because they don't answer the question. You must make a statement. The oxidizing agent is ClO-. And by the way, if you left out that minus, that would be tough. You'd lose all the marks. You didn't name the right species. Okay, very important. That is the oxidizing agent. Okay, it's reduced. That's the reducing agent. It's oxidized. Very good. That's the first part of that. Okay, use oxidation numbers or otherwise to balance either equation. Now I'm going to balance both for you, so we just need to get used to this. Okay, we'll continue with our method now. Okay, that's a lovely question now, folks, for 25 marks. All 25 marks in the bag. Be very careful. Balance any one of them. We're balancing this now. Okay, I've this done. Identify what's oxidized and reduced and balance the electron transfer. Now be careful with this, won't you? I've told you if that was a 4 now, this would be a 2, and to be 1 to 1 there, that'd be very dangerous. Okay, so 2 electrons are being gained, 4 are being lost, so I need a 2 there. 2 2s are 4. So the electrons are balanced. And you know what I'm going to tell you next? Under no circumstances can this ratio be tampered with now. That's 2 to 1. Under no circumstances can that be tampered with. That's very important. Okay, and we're going to work on that then. Reduce, okay, and that's what you're at more than anything else, and that's excellent. 2 of that, 1 of that, excellent, right? That's what we're at. Now balance the remaining atoms by inspection. Starting from the left. 2 chlorines on the left, there's only 1 chlorine on the right, I'm putting a 2 in there. Good. Oxygen, leave it to last. Remember that? Sulfur 2, I've only 1 here, put a 2 in there, the sulfurs are balanced. Oxygen, leave it to last. Okay, hydrogen and oxygen, and hydrogen I'm leaving them to last. I have nothing else left, so that's good. Now what am I going to do here? I see hydrogen on its own, so you balance hydrogen last. If it's on its own, it's not tampering with anything, balance the oxygen before the hydrogen. That's on its own. Watch me now, please. Balance the oxygens first. Here we go. 2 oxygens, and 3 oxygens is 5, and 1 is 6. Oxygens, okay? 6 oxygens. Now have I 2 there already? I have. Okay, and on this side at the moment I have 4 2s or 8 oxygens. I have 8 oxygens on the left hand side. 4 2s or 8. On the right hand side, 2 oxygens, 3 oxygens, 5 oxygens. 1 is 6 oxygens on this side. 6 oxygens on this side. Okay, and I need to balance that. Now, the way to do that, of course, is I need 2 more oxygens on that side. If I put a 3 in there, I'd have 2 oxygens, 3 oxygens is 5, and 3 would be 8, and 4 2s is 8. So that's the magic number 3. Are you okay? Put the 3 in there, and that's going to become 8 oxygens. 2, 3 is 5, and 3 is 8. Very good. Now, did you hear what I said originally? People trying to balance the hydrogens first get into trouble. If there's something on its own, you balance it last. Now that's easy. There are 3 hydrogens there. So you need to put a 3 in here, and that's lovely. And that should balance. Okay, and what you're doing. Do you want me to apply the theory about balancing charges? Now folks, that would be tricky. And the success rate in that wouldn't be great. And I want to tell you now, they said to you there, balance either equation, meaning you mightn't balance both. Now, I would be a bit uneasy about that now. My attitude would be you either get it all right or you still have work to do on it. Now, please, I hope you'd be okay with that. And you should try that again yourself now. Okay? You start from scratch with a clean page with these and you work away. Give yourself loads of room here and obey the rules. Working from left to right, leave hydrogen and oxygen to last. And if something is on its own, it should be the last number to go in. I wonder how the charges on that. You have 2 minuses. You have 2 minuses is 4 minuses, and 3 minuses is 7 minuses. 7 minus on the left. This doesn't always work, by the way, if it's balanced, but let's look. You have 2 minuses and 2 minuses here, okay, and you have 3 hydrogens, you see, and that's going to cancel that, so there's a problem with that one, but it's fine, it's balanced, you have no issue with that. Just take it, please, will you? That's why they've put in the either there. There may be issues with 1 or 2 of them. I'm going to take the second one for you and see how you'll balance it. The second equation has a different chlorine ion, okay? This is the chlorate ion, ClO3. ClO3 minus plus Br minus plus H plus goes to Cl minus plus Br2 plus H2O. Now folks, I very much need you to be in a position here where you try these, where you start with a clean page and you have nothing to declare but your genius. You'll be amazed how well you're up on this if you're following the right sequence, and I'd like to think you were doing that now, okay? Now please, it would be a great help if you took it down correctly. There's a minus there. Watch the minuses on these papers, even though with the new font they're still difficult enough to read. There's a minus there, and there's another minus on the other side. Be particularly careful with them, won't you? Here we go. Minus 2 3 times. Okay, so that chlorine must be plus 5. Minus 1 is simple ion, plus 1 is simple ion. Minus 1 is simple ion, 0 for a free element, minus 2 plus 1 twice. And you have to balance them as you go along then, okay? Now identify what's oxidized and reduced. I see the chlorine has gone from plus 5 to minus 1. That's a decrease. That's a decrease. That is reduction. Reduction is a gain, and it's a gain of 6 electrons. Are you okay with that? Plus 5 to minus 1 is an interval of 6. 6 electrons there. Very good. Okay? And now, leave the oxygen. I see bromine is going from minus 1 to 0. Minus 1 to 0. That is an increase. That's oxidation. Oxidation is a loss, and it's a loss of a single electron. Loss of a single electron, okay? Identify what is oxidized and what is reduced and balance the electron transfer. This is losing 1. This is gaining 6. So you need a 6 there. 6 ones to balance the 6. Now you can't touch the 6 to 1 for the rest of this balancing. Keep that in mind. You can't balance that, okay? That's that done. Very good. Now we'll balance the remaining atoms by inspection. Chlorine on the left one, chlorine on the right one. Good. Leave oxygen to last. 6 bromines, put a 3 in there and you have 6 bromines. Very good. That's the bromines done. And lastly, hydrogen, and we're leaving that to last. Hydrogen is on its own. Where did you hear this before? Balance that last, balance the oxygens firstly, okay? There was a hydrogen on its own there. It's a lifesaver when you do that. We'll do the oxygens next then. There are 3 oxygens here. So you put a 3 in there and the oxygens are balanced. And finally the hydrogens. 3 2s are 6, and you put a 6 in there and that will balance for you, okay? And you're doing all right there with that, okay? Now I did say a while ago about, if you fail to balance by inspection, try balancing the charges. Balance by inspection firstly, because the charges don't always balance. There can be a species missing or something in the equation. Now that one was probably slightly easier to work with than the other one, but that's not the point. You get very good at this when you have a sense of the sequence in which you do things. What do you do before what? You always assign the numbers first. You identify what's oxidized and reduced, and you balance the electron transfer. Okay, now you can't touch that ratio anymore. I've mentioned to you already. You can't touch that ratio anymore once that's done. Okay, now balance the remaining atoms by inspection, leaving hydrogen and oxygen to last. I balance that, I skip that. I balance that, I skip that. Now I go back and see what's on its own. The hydrogen's on its own, so balance the oxygens first and balance the hydrogens last. You get very good at this now, I promise you, but you need to practice. And you need to be aware of the sequence in which you're doing things if you're going to do them refined. 25 marks for that. You had to do any one of them to get the 25 marks. That's very good. That's very good and that's very satisfactory. You could do very well in that. I'm going to look at number 14 next. Okay, make a note, please. It's the year 2014, and the question is question 10C. Question 10C, it's in the bottom of the screen here, okay, 10C. Now take your time with these. Make a note now, please. Again, it's very important everybody has a note of what I'm putting up on the board. Are you okay with it, please? Okay, I'm repeating 2014, question 10C. Even if you haven't access to that immediately now, please, you need to identify that it's the answer to that question so you can read it. I'd like to think you had the question, that you could pause the video, that you could go and look at this question and read it, and then you could come up with an answer to it. Now, I just need to take down the equation. These are, I've already said, you know, I know I'm repeating myself, but question 10 and 11 are 3 parts of which you must do 2. And usually one of these is very controlled in that I would say to you could score full marks on this question. It would be very popular question 10, okay? Because you're only doing 2 parts. And of course, something like oxidation reduction will get you all the marks. You're asked to define the term, define in terms of electron transfer and oxidation number, okay? You're defining oxidation in terms of electron transfer. Oxidation is a loss of electrons, and you have 3 marks in the bag. And define oxidation in terms of change in oxidation number. It's an increase in oxidation number for the other 3 marks. Use oxidation numbers to identify the oxidizing agent and the reducing agent in the following reaction. This is cadmium Cd. You don't see that very often. Cadmium plus H plus nitrate ion NO3 minus goes to cadmium Cd2 plus NO plus H2O. And they're asking you, use oxidation numbers to identify the oxidizing agent and the reducing agent in the following reaction. Hence or otherwise, balance the equation. Will you ignore the otherwise? Generally speaking, you'll have to use oxidation numbers to balance it. And that's what we're going to do, all right? So I'm starting with that now. I'm going to put numbers on it. I hope it'll be all right. That's a free element. That's a simple ion. Minus 2, 3 times for oxygen. Therefore, that's plus 5. A simple ion plus 2, oxygen minus 2, so the nitrogen is plus 2. Minus 2 plus 1 twice. Can I remind you again now, please, my arrows here? They are a deduction. When there is no rule about nitrogen, and there isn't, then you deduce what it is. Are you clear on that? Whereas the rest has rules going with it, and that's why they're up there, okay? Use the arrow, please, it keeps things tidy. So we start from left to right now and identify. That goes to there. That is an increase. Okay, that is oxidation. Oxidation is a loss, and it's a loss of 2 electrons. And I'm looking at nitrogen going from plus 5 to plus 2. That is a decrease. That is reduction. Reduction is a gain, and it's a gain of 3 electrons. 5 to 2 is a gain of 3. Identify what is oxidized and what is reduced. The question asked me, use the oxidation numbers to identify the oxidizing agent and the reducing agent. How are you fixed? The oxidizing agent has been reduced, so that's the oxidizing agent. NO3, the nitrate ion, okay? NO3 minus. You'd have to write that down now in the leaving cert. You'd have to write down the oxidizing agent is NO3 minus. And if you leave out any part of that detail, you get no marks. Okay? And the reducing agent is oxidized, so the reducing agent is the cadmium Cd. Okay? That's what they wanted for that. Very good. And they've asked you then to balance the equation. Hence or otherwise, balance the equation. Now that's a soft question by any stretch of the imaginations, okay? Now balance the equation. Identify what's oxidized and reduced and balance the electron transfer. This fellow's losing 2, this fellow's gaining 3. Losing 2, losing 6, gaining 6. 2 3s and 3 2s. Now, here I go again. You can't touch that ratio for the rest of the balancing. You can't touch it, okay? So we have 3 cadmiums here, and I'm going to balance the rest by inspection. 3 cadmiums, so I need a 3 there. Very good. Leave hydrogen to last. Here I go again. Pass over it. Nitrogen next. 1 nitrogen, 1 nitrogen. And oxygen is next. I need to balance them. Now, I see the hydrogen is on its own. Leave it to last. Balance the oxygen firstly. 3 oxygens. 1 oxygen and 1 oxygen is 2, so I need to balance that. Don't change that one because you'll change the nitrogen. Change this one. I'm saying that again to you now. 3 oxygens here, 1 oxygen here, and 1 oxygen here. I need 3 oxygens, so I'll put a 2 in there, and that will bring the oxygens up to 3. Very good. And the hydrogens now are easily balanced. What am I saying? Hydrogen on its own. Yeah, be careful here now. I'm going to show you something happen. Okay, that's 2 oxygens. Okay, that's fine. There's no problem with that. Now be careful. In this particular instance, you must be careful how you follow that up. Okay, I'll go back to it again now for you to make sure everything is okay. That's a 0. That's a +2. Therefore, there's 2 electrons lost. Okay, that is as you're writing it there now. Be careful you have all them correct. There wouldn't be any issue there. This one is going from +5. Okay, +5. To +2, and therefore that's right, and the ratio is 3 to 2, a 3 there and a 2 there. Okay, now the rule is very simple here now. You can't tamper with that. You can't tamper with that, so maybe we need to review that again. Maybe it is the oxygens you'll be better looking at in terms of what you need there. We have 3 oxygens here. I have 1 oxygen and I have 1 oxygen here. I might get away with, getting away with that. Yeah, in this instance we'd want to be careful how we're presenting that. I've made a mistake. Can you see the mistake I've made? Very serious now, okay? 3 and 2. That 2, silly man, should be here. Haha. Now please, have a good laugh at me now, please. That's a serious mistake, okay? Can you see? 3 and 2. Look at my arrows. I didn't follow the arrows. I put the 2 in there by mistake. And I was about to say, I can't touch that one. Okay, be very careful now. Other than that, it's fine. I've no problem. So I better go back and balance again. 3 here and 2 there. That's right. Okay, 3 cadmium is fine. Next, you have 2 nitrogen here. So I must put a 2 in here. Okay, I must put a 2 in here for the nitrogen. Very good. I've left the hydrogen and oxygen to last. The hydrogen on its own, so leave it to last. Do the oxygens next. 3 2s are 6. Now, let me get rid of this again. Why is that there? Let me get rid of that again for a moment. Leave hydrogen last. 3 2s are 6. 6 oxygens. I have 2 oxygens here. I need a total of 6, so I'm going to put a 4 in there. And that's 2 oxygens and 4 oxygens, 6 oxygens, and hydrogen last. 4 2s are 8, and the 8 goes in there, and you're on your way. And that's fine. That's exactly what you want. There'd be no issue with that. As it happens, the charges on that will balance. There's a +8 and a -2. That's +6, and there's a +6 there. But that's neither here nor there. That's the balancing. Now be careful. Anyone will make a mistake here if you don't do things right order. I put that number in there by mistake. Now that's very serious. Because you can't tamper with that anymore. You can't tamper with the 3 to 2 anymore. That's very important. In the next unit, I'm going to show you an exam question where you were nearly obliged to tamper with the ratio and it created all sorts of problems. Okay? Now, please be very careful that you're getting it right. And that's a lovely question now. You should be getting all the marks in that. Just take a bit of care now, please. The loops need to be big to make sure that that's okay. All right? That one and that one are the 2 that you're dealing with there. Very good. So that's that. And that is 2014. Very good. I'm going to look at 2008 now for a particular reason, okay? 2008. Will you make a note, please? 08, 2008, and it is question 10B. Question 10B, okay? 10B. Maybe I'll just highlight it there for you there. That's the one you're dealing with, this one here. Now, I realize that, you need to have the original to deal with that. It's very, very important. Now, you get very good at these as it happens. You get a great sense of satisfaction out of this and you'll feel you're in control. But you do need to realize we all make mistakes now, and be careful because it becomes very, very awkward. I'm reading it for you. Define in terms of 2008, okay? Define in terms of define oxidation in terms of electron transfer and change in oxidation number. Fairly similar stuff, isn't it? Oxidation is the loss of electrons, okay? And it is an increase in oxidation number, 7 marks for that. For the redox reactions shown below, use oxidation numbers to identify the species oxidized in the first reaction and the oxidizing agent in the second. Now be careful that you're reading that correctly. And part 4 there, they've asked you, the second part, third, fourth part of it there, they've asked you clearly, using oxidation numbers or otherwise, balance both equations. So that's a bit of a demand for you, okay? So we have to take each of them in turn and answer the parts as we go along. So I'm going to take the first one for you now. These can be quite familiar at times, but don't worry about them. They could be a titration you've done already or something. ClO minus plus I minus plus H plus. In the next unit, I'm going to demonstrate that for you. That is the test you would use for an oxidizing agent. Okay, bleach is an oxidizing agent. If you put it into acidified potassium iodide, which is colourless, you'll produce iodine. You'll produce Cl minus, I2, and H2O. Now, I'd expect you to know that. I don't mean the equation. I'd expect you to be able to describe that test. How would you test for an oxidizing agent? You take any oxidizing agent and put it into acidified potassium iodide and it will turn brown. Okay, for reasons that we'll deal with in a moment. Now, we better just assign oxidation numbers to that firstly and then go through it. Now, can I stress to you the importance of having everything down correctly? Please now, that's very important. There's about a 5% fallout every year in chemistry with people. Transfer of information onto the manuscript is poor. Please go back and double check you have it down correctly before you start working on it, because it will be a waste of time otherwise. Okay, oxidation numbers then, minus 2, therefore that must be plus 1. That must be plus 1, yeah? Simple ion minus 1, simple ion plus 1, simple ion minus 1, free element 0, minus 2 oxygen, plus 1 twice for hydrogen. Identify what is oxidized and reduced. The chlorine goes from plus 1 to minus 1. That's a decrease, that's reduction. Reduction is a gain, and it's a gain of 2 electrons. Very good. And I see the iodine is going from minus 1 to 0. Minus 1 to 0 is an increase. That's oxidation. Oxidation is a loss, and it's a loss of 1 electron. Are you okay with that? And so we balance the electron transfer. Now, they asked us a question on that. I better deal with it. For the redox reaction shown below, use oxidation numbers to identify the species oxidized in the first. The species oxidized in the first is iodine. Will you be careful, please? If you said iodine, you get no marks. It's not iodine, it's I minus. Okay, and will you be aware of that, please? The species. Do you know what that word species means in chemistry? It could be an atom, it could be a molecule, or it could be an ion. Will you be aware of that, please? It's very important when you're working like that, that's what they're dealing with. Please now, what has been oxidized? I minus. It's called the iodide ion. Did you need to say that? No. If you said I minus and it was clear, you said this is the one oxidized, the I minus, that's fine. But please look, iodine is over here. That's iodide, be careful. You were asked then, I'm repeating again, the species oxidized in the first reaction. Okay, and then they ask you, using oxidation numbers or otherwise, balance both equations. So we're going to balance this equation now. Balance the electron transfer. I need a 2 there. This is gaining 2, this is losing 1. I need a 2 there, that's good. So the electrons are balanced. Now, balance the remaining atoms by inspection. Okay, you can't touch the ratio 2 to 1, now be careful. Starting on the left, 1 chlorine, 1 chlorine. Oxygen, leave it to last. 2 iodines, they're balanced. And hydrogen, we're leaving it to last. Because hydrogen is on its own, balance the oxygen firstly. Are you okay? We have 1 oxygen there, you have 1 oxygen there, they're balanced. 2 hydrogens, and so a 2 goes in there, and you're fine. And that's exactly what you want. And by the way, the charge is balanced there. 2 minuses, 2 pluses is not. There's a single minus, there's a single minus. You're spot on. That's balanced, okay? Very good. That's that one, and that's what they're looking for. The second equation you're asked to balance as well, okay? Now, the method is the same, irrespective of the equation. You need to apply it that way, it's very important. This is I2 plus thiosulfate, S2O3, 2 minus. Now, don't be anyway intimidated by a new chemical, please, okay? Something, I haven't seen that before. What does it matter? It doesn't matter at all, okay? Don't be anyway intimidated by that. Goes to I minus plus S4O6 2 minus. And that is your equation, okay? Iodine, thiosulfate goes to iodide, and the tetrathionate. Now, don't worry about it, but that's a standard titration. Iodine, thiosulfate titration. Not relevant, other than you must inspect what's in front of you, and to be nice if it was down correctly again. Please be careful that that is very important. Assigning oxidation numbers then, free element 0. -2 for oxygen 3 times. That therefore must be a total of +5. Am I right? Be careful now. Be careful now. -6. Okay, that must be +4. So that must be +2 twice. That's +4, that's -6, and that's -2 is correct. Okay, that's a simple line. -1, that's -2. Be careful here now, please. -2 6 times. What must that be? -2 6 times. That whole thing must be +10. There's 4 of them there. +2.5. How are you fixed? Now please, I'd prefer a half there, a fraction, to a decimal, because I think it might be hard to see. Okay, that's okay, by the way, it's not half a molecule, it's half a mole, so don't worry about it, okay? Don't worry about it at all, that's fine, a half is quite okay there. Now please be careful there, they're playing with your head a bit, but be careful. That has to be 10, that's 12, -2 is correct. Now that's probably the most difficult thing there, will you be careful with it? I'm about to deal right now, what's oxidized and what's reduced? Identify, the iodine goes from 0 to -1, that's reduction. Reduction is a gain, it's a gain of a single electron. And the sulfur goes from +2 to +2.5. That's an increase. That's oxidation. That's a loss. And it's a loss of half an electron. Are you okay? Oxidation is an increase, okay? And oxidation is a loss of electron to half electron. Now that's grand. Don't worry about the half at all. We half a mole, but the ratio is 1 to 2 anyway. So you're going to need a 2 there, 2 halves to make up the 1, and there you go. Now, please watch that, because that's the kind of trickery they play with now to see, have you an awareness of that? That's quite okay. That's quite okay. Oxidation numbers at the half is fine. There's no problem there. Okay, and so you have that balanced. So that's the electron. Identify what's oxidized and reduced, and balance the electron transfer. Now I'm reading again what's here. It asks you to identify the species oxidized in the first one, the iodide, and wait for it, and the oxidizing agent in the second one. The oxidizing agent is the substance reduced. And that's why I'm saying it to you. One answer is I2 and the other is I-. The first answer was iodide, or the iodide ion, or I-, and the second one is iodine. Iodine is the oxidizing agent. The oxidizing agent is reduced. And they've asked you to balance that as well now. Let's do that. We have already balanced the electron transfer, right? I'm balancing, starting by inspection then, 2 of this. I need a 2 here. Good. Sulfur is next, 4 here. I have a 4 here. And the oxygen last. I have 6 here and I have 6 there. That's balanced. That was straightforward enough. But that was the trick here. A lot of people will get that wrong now. Now, please, you need to revisit these again in your own space, in your own time, with the idea that you're getting them right. And, will you pause the video if you think, you need to take a bit more time over something? That would be a good idea, because it will give you a sense of where you're going with it. And that's very important. Now, let me do one more with you. This is 2013, more recent again now, and I'm mixing this one a bit because there's a bit of stoichiometry in as well. It's 2013, question 10b. 2013, question 10b. Okay? Now, 2013, question 10b. Now, please, folks, it's very important you make a note of each of the questions, okay? That you have a list of them all. The last one I did was 2008, okay? And will you be aware of that, please? It was question 10b as well, okay? Now, this one is a bit more demanding, this one here, because there's a bit of stoichiometry in it as well. But it is oxidation as well, and we have to be careful of that. The following... Now, have I got this right for you? What we're dealing with here, yeah. The following redox reaction is highly exothermic and is used to produce molten iron for welding pieces of steel together. For example, sections of a railway track. Now, they love to do that. They love to give you as kind of a relevance of the equation you're dealing with. It's a distraction. in most cases, but like you have to read it and make sure there's no piece of information. There isn't, other than making a statement, okay? So they're producing iron there, okay, for welding, and that's what they're doing in this instance, and there's no issue with that. So you give it, define oxidation in terms of change in oxidation number, and you're going to say oxidation is an increase in oxidation number to get your marks, okay? Show using oxidation numbers that this is a redox reaction and identify the reducing agent. Very good. So we have to do that. Let me take down the equation for you. I'm writing it in red again for you. That's aluminium, and you've 8 aluminium plus 3 Fe3O4. And you have 3 of them there. Just make sure you're spread them out well, please, when you're doing balancing, because you need space for writing. Aluminium oxide, Al2O3, and you have 4 of them. And lastly, you have iron, and there's 9 iron there. 9 iron there at that. Okay, so you have 8, you have 3, you have 4, and you have 9. Be careful, okay? Just in dealing with that, that's very important. Show using oxidation numbers that this is a redox reaction and identify the reducing agent. Okay, free element, 0. -2, 4 times. Okay, be careful here now. Okay, that's 8, and you have 3 there. So what are you going to do with that? Are you all right? Is what you're going to do with it? Okay, you have 8 there, you have 3 there. Okay, you're going to have to work that out. 8, okay, and you have 3 there. Okay, divide that by 3, you're going to get 2. Okay, and you're going to get 2/3. Okay, that's 2 and 2/3, isn't it? That's what you have there. That'll be plus 2 and 2/3. 2/3 by 3. Now, folks, I am saying this to you. Don't worry about it. Don't worry about the fraction. Don't use a decimal now, use a fraction. Okay, it's much better. Okay, that's -8, and that should be +8. Are we okay with that? That's 2, and 6 is 8 is right. Okay, now be careful with that, please. But they're messing with your head a little bit there now. Just be careful how you're dealing with that. On this side, -2, 3 times. Okay, so the aluminium should be +3 twice. Okay, +3 twice. They've asked you to show, okay, can you see the equation is balanced here, and you forget about the balancing numbers. Show using oxidation numbers that this is a redox reaction. Okay, you're still doing the same thing, even though you're not going to be balancing in this case. -2, 3 times, therefore that must be +3 each, very good, and that's a free element. Okay, 0. And show, now there you go, there's nothing more to it than that. And here we go, right? Aluminium goes from 0 to +3. That is oxidation. Oxidation is a loss. It's a loss of 3 electrons, very good. And the iron goes from 2.5, 2 2/3 to 0. That's reduction, it's a decrease. That is a gain, and it's a gain of 2 2/3 electrons. I must tell you sometime about 2/3 of an electron. We could be talking moles here, okay? 3 moles and 2 2/3 moles of electrons of a grand. Okay, but don't worry about it now. Don't be thrown by fractions. That's the reality. It's the fact of the matter is that it is, in this case, that it is decreasing. So it's reduction, it's a gain. All right, are you all okay with that? And that's what you're, now, that literally would appear on your paper, I hope. Make them legible now. Give yourself big loops here so you've loads of space, okay, in dealing with that. And it says, show using oxidation numbers that this is a redox reaction, okay? And that's all you have to do. There's nothing more to it than that, you're fine. Okay, and you've shown it there now. Make a statement along the lines of, okay, the oxidation number of aluminium has increased, okay, therefore it's oxidized, and the oxidation number of the iron in the iron oxide has decreased, so it is reduced. And that's what you're saying, and that's it. Once you've shown the numbers, you'd have shown that. Put in the loops, please, and you said that, okay? I would make a statement now that aluminium has been oxidized and Fe3O4 has been reduced. Now that's a little novel twist. They're looking for different ways of asking the same thing. They gave you a balanced equation. In this case, the rule simply was, I'm not saying you do this now, but you ignore the balancing numbers. You ignore them, okay? You have to still work on the rest. The numbers are not there. And that was throwing a lot of people now. They're trying to multiply that by 3 and things like that. Don't do that. Don't do that. Leave it like that, okay? Stay with your tried method and you'll be fine. There'll be no issue at all with that. Now, that's why I've brought this one to your attention. It's a little bit quirky, a little bit different, okay? And you must be ready for that. I keep telling you, a good method is ready for all options. It says identify the reducing agent. The reducing agent has been oxidized, so the answer is aluminium. Okay, Al, aluminium is the answer. Okay, it's been oxidized, so it's the reducing agent. Now the next bit is a blast from the past, and we have to deal with that. It says, what mass of aluminium powder is required to produce 1008 grams of molten iron for a single railway track weld? What mass of aluminium oxide is produced as waste in the process? Now, I don't know whether you realize it or not, but you've been given a full balanced chemical equation and one quantity. So we're back to our mole strip. And I hope you're realizing that now. Just what you're given in the question that gives you that. I'm scrapping that. Okay, I'm sorry about these now. Let's put them back again for you. Okay, but then the full balanced equation, and we're going to work with it, all right? And that's good that I would do that we'd have a sense of where you're going with that. And so they are. There's 8 aluminium, there is 3 iron oxide, you have 4 of them, and you have 9 of them. Now be careful, won't you please? As I said, they're playing a little bit with your head. They're always trying to identify the rote learner. And don't become a rote learner. There's a concept here. If you have the concept, it doesn't leave you. Your strategy, here's how I deal with this. They gave you this, but they asked you about oxidation reduction, and that was quite straightforward. They've asked you what mass of aluminium powder is required to produce 1008 grams of that. Will you be very careful now, please? I said 108 there because a number of people would have used 108 there instead of 1008, and that's a problem. Okay, will you be careful, please? That's the only quantity given now. That quantity is given. Okay, so I'm going to make up the mole strip for you. It's the easiest way to do that. The ratio strip for a start. Okay, let me break away from that now. The ratio strip is as follows. That's 8, 3, 4, and 9. Convert that to moles. Okay, do you know how to convert that to moles? 1008 grams. You divide by the AR, which is 56. And I got 18 moles for that. I told you already they'd be cooked. 18 moles is what they are, okay? And you can work any way you like with that. Okay, 9 and 4 there, 2, that would be 8, would it? That one there, and you work with them. Now I'll go with them in a moment, but I just want you to see first of all what you're at there, okay? You have an 8 in that, you have a 6 in that, yeah, and over here with the 8, what have you got? 2, you have 16 there, yeah? You have 16 there, I hope you have. All right, that's what you have, and you work with that as best you can. Are you okay? They're all ratios now. I'm not going to go there with you now, but take your time. 9 moles, okay? Okay, the ratio is 9 to 4. So divide by 9, you get 1 multiplied by 4. Okay, divide by 9, you get 2, and 4 is that. Are you okay with that? Divide by 9, 2 by 3, multiplied by 3, 2 by 8 is 16. And that's good. They're the number of moles. Now you've answered the question practically at this stage. But for usually, you're getting a detail over here, as you know. In this case, they gave you that, and that's the ratio between them. What mass of aluminium powder is required, okay, to produce that many grams of molten iron? So you have 16 moles of aluminium, and that's your answer, except you must convert it to grams. That's equal to 16 multiplied by aluminium is 27, and that's going to give you 432 grams of aluminium. A number, a unit, and a tag, please. Very important, right? Good. And the next one, they asked you what mass of aluminium oxide is produced. There's aluminium oxide, 8 moles is what you have there. Am I right? Have I that right? 8 moles. Why am I? Yeah, 8 moles of aluminium oxide is right. 8 moles of Al2O3, and you multiply that by its MR as well. That's equal to 8 multiplied by, I got 102. 102 is the MR for that, 2 aluminiums and 3 oxygens, okay? And that came out as 816 grams of Al2O3. A number, a unit, and a tag, please. Now, please, there is no excuse for not getting full marks there. Now, as a result of our work over the last 2 months, in video particularly, I am saying to you now, you should be in a position to revisit them with a sense of confidence. Now, what I'm going to ask you to do is, in our next unit, I'm going to show you the test for an oxidizing agent and reducing agent. And there's a mandatory experiment in this section, which is not listed on my study plan, and I'll be doing it in the next unit. But I'd ask you now, please, as a priority, go back in this section on oxidation and reduction. It's terribly important that you have the basics right. If you have, there's loads of questions you'll have access to throughout the whole system, and I'd ask you to do that now. We're down as far as here now. I've down to bottom number 6. Laboratory tests and the mandatory experiment. I have them listed there. I'm going to list it for you the next day, and we'll have that section wrapped then. There's quite a bit in it now. I'll have a look at 1 or 2 more questions when you have that done, but do a bit of revision now, please, up here. Make sure you're very clear on your rules, your exceptions, and you have good method. Now pause these videos if you're in doubt and go back in them. Sometimes it's good to hear it a little bit more, but then you need to switch off, take the question, take a pad, and start like I do on the board and come up with your answer with your calculator. And you'll be pleasantly surprised how strong you are with the subject. All right? Good.